Hey everyone, and welcome to The Explainer. I am so thrilled you're joining us today because we are going to break down some incredibly complex, totally mind-bending science. But we aren't looking in a lab or a dusty textbook. No, we're looking right in front of us, at the science hiding in plain sight in our everyday routines. We interact with absolute miracles of physics and engineering every single minute without even realizing it. So my goal today is to completely change how you look at your daily life by visually unpacking the magic all around us. Let's dive in.
Here is our roadmap for today's explainer. We're going to cover 4 main areas: the magic in your hands, everyday life engineering, secrets of the human mind, and finally, invisible forces in space.
All right, let's kick things off with Section 1, the magic in your hands. We'll be looking at touchscreens, Wi-Fi, Bluetooth, and algorithms. Take a quick look at your phone screen for a second. Every single day, you are swiping, tapping, and scrolling on that glass. But how does it actually know exactly where you touched it? Most people just assume the screen is feeling the physical pressure or the force of your finger pushing down. But that is actually a complete myth. The truth is way more mind-blowing. The screen isn't feeling your pressure at all. It's feeling your electricity.
So beneath that glass, there is a completely hidden, highly transparent grid of microscopic wires. This is known as a capacitive touchscreen. A very weak electrical current is running through that grid 24/7. Now, the human body happens to be an excellent conductor of electricity. So when you place your finger on the screen, you are literally stealing a tiny fraction of that electricity. Your phone's processor is constantly monitoring this grid. At lightning speed, it calculates the exact intersection of longitude and latitude where that voltage dropped, and it says, oh, current was pulled from the top right corner. Open that app. It's brilliant. And it perfectly explains why you can't use a pencil, a car key, or thick winter gloves on your screen. They don't conduct electricity, so they can't steal the current.
Now, knowing what you want to tap is one thing, but fetching that data from the internet is a whole different ballgame. That brings us to Wi-Fi. Wi-Fi essentially sends tiny waves through the air, kind of like radio waves, but vastly faster. Your router takes internet data, like a funny cat video, translates it into zeros and ones, and shoots it through the air on specific pathways or channels. Modern Wi-Fi is actually so smart, it can focus the signal directly at your phone like a laser. And if you've ever wondered how your router doesn't just get completely confused by your neighbor's router, it's because they use different channels, and the data is locked with a secret code. If another device tries to eavesdrop, all it hears is encrypted noise. It is a hyper-fast conversation happening billions of times a second.
Which brings us to another wireless wonder, Bluetooth. By the way, fun fact, it's actually named after a 10th century Viking king who united Scandinavian tribes. So today, Bluetooth unites our devices. It acts as a mini, weaker version of Wi-Fi using short-range radio waves. But picture a crowded coffee shop with dozens of wireless headphones and smartwatches everywhere. How does your audio not accidentally play on a stranger's headphones? Well, the secret relies on the number 1600. Bluetooth uses this genius technique called frequency hopping. It slices your data into tiny packets and rapidly hops across 79 different secret channels. Get this, it changes channels an astonishing 1600 times every single second. Your phone and your headphones agree on this jumping pattern in advance, which makes it mathematically impossible to collide with someone else's signal.
So the hardware in your hand is clearly amazing, but the software running on it is equally mind-bending, especially the YouTube algorithm. Have you ever watched one single video about a raccoon, and suddenly your entire homepage is just 87 videos of raccoons driving cars and going to space? This algorithm is a giant supercomputer. It mixes what you like with what people similar to you like with what was randomly trending 3 years ago at 2 a.m. It doesn't actually know why you want to see a video, it just mathematically knows that you do. Its sole driving purpose is to feed you exactly what will keep you clicking and watching indefinitely.
To pull that off, the system is watching your every single move. It tracks what you click, if you pause, if you rewind, if you bail halfway through. If you click but don't watch, well, that's bad. If you watch but don't click anything else, that's okay. But if you click and watch video after video, the algorithm basically says, feed them more. It is constantly comparing your habits to millions of others. Say 800,000 people watch a video on tying a tie, and then immediately click a video on life management. The algorithm links those two and instantly suggests it to you. It's essentially building a custom simulation of your brain. Moving right along to Section 2, Everyday Life Engineering. We'll be exploring microwaves, noise cancellation, and GPS.
Okay, we have all been there, right? You put a frozen lasagna in the microwave, and when it comes out, the edges are literally boiling lava, and the center is still in frozen hibernation. Or you heat up a slice of pizza, and the crust turns into a rubber car tire. Why in the world does this happen? Well, it's because a microwave doesn't use fire or traditional heat at all. Instead of traditional heat, a microwave shoots invisible electromagnetic waves. They're kind of similar to X-rays or light, but heavier. And these waves target one specific thing, water. See, water molecules have a positive end and a negative end. When these waves hit them, they force those water molecules to vibrate and shake millions of times per second. All that violent shaking creates friction, and friction creates heat. So things with lots of water heat up super fast, while dry things get all weird and rubbery. But here's the kicker. These waves can only penetrate about 1 or 2 inches deep into the food. That is exactly why the outside boils while the inside stays frozen. And because the waves bounce around randomly inside the box, that spinning glass turntable, that is the real hero. Without it, half your meal would be incinerated and the other half frozen solid. Now, moving from the kitchen to your morning commute, active noise-canceling headphones are another everyday physics miracle. When you turn them on and the roar of a jet engine just vanishes, your headphones aren't just acting like thick sponges plugging up your ears. It is actually an active, brilliant application of physics called destructive interference. Tiny microphones on the outside listen to the chaotic noise around you. They send that sound to a smart chip, which instantly creates the exact mathematical opposite of that sound wave. So if the engine noise wave goes up, the headphone creates a wave that goes down. When it blasts this inverted wave into your ear, the two waves physically collide and erase each other. They equal 0. You are literally fighting sound with more sound to create absolute silence.
And it's not just your headphones working magic on your commute. When you open a map app, a little blue dot instantly knows exactly what street you're on. To do this, your phone relies on a magic number, 24. That is the network of 24 GPS satellites currently hurtling through space around the Earth. The secret to your location isn't on the ground at all, it's floating up in the cosmos.
Here's how this rapid triangulation actually works. Your phone doesn't talk to the satellites, it just listens to them. These satellites constantly scream out 2 things. Here is exactly where I am, and here is the exact time. Your phone catches signals from at least 4 of these satellites at once. Because the signal travels at the speed of light, your phone calculates the tiny time delay to figure out the exact distance to each satellite. It basically draws 4 massive intersecting circles, and exactly where they meet is where you're standing. But here is the absolute craziest part. Because these satellites are moving incredibly fast and experiencing less gravity than us down here, time actually moves slightly faster for them. This is exactly what Albert Einstein predicted with his theory of relativity. If scientists didn't program your phone to constantly correct for these microscopic fractions of a second, your map would be wrong by 10 kilometers and you'd end up driving straight into the ocean.
All right, let's move to Section 3, Secrets of the Human Mind. We're looking at the biology behind handedness and dreams.
First up, ever wonder why only about 10% of people are left-handed? It really all comes down to brain management. Your brain is split into 2 halves, right? The left side controls the right side of your body, and the right side controls the left side of your body. For 90% of the population, the left brain acts as the dominant boss, so they end up being right-handed. But for that 10% of left-handed individuals, the right side of their brain simply has a louder voice and takes control, letting the left hand steal the spotlight. It's just a simple, fascinating quirk of neurological hierarchy.
But what happens when that brain goes to sleep? Dreams are just wonderfully insane. You can go to bed thinking about a bowl of cereal and wake up feeling like you just gave birth to a dragon on a trampoline while your old math teacher clapped. Why? Well, during REM sleep, your brain is actually working incredibly hard and a giant simulation engine. Scientists have a few main theories. It might be sifting and organizing messy memories, kind of like cleaning up a chaotic computer desktop. It could be emotional therapy, converting psychological trauma into a talking animal so you can safely process it. Or it's threat practice, your primitive brain running drills on how to escape a tiger. And because your brain's logic filter is completely powered down for the night, you don't even question it. That is why fighting a dinosaur with a spoon feels like a perfectly normal Tuesday in dreamland.
Finally, we reach Section 4, Invisible Forces in Space. It is time to confront the final boss of the universe. Yep, I'm talking about black holes. When a massive, exhausted star burns through all its fuel, it just collapses inward. It caves in on itself like a giant cosmic pothole, creating an area of gravity so pure and so terrifying that it literally pulls things in forever. The event horizon is the absolute border of this phenomenon. It's the absolute point of no return. If you cross it, game over. Absolute silence. No signal escapes. Not even light, which is the fastest thing in the universe, can bounce out of it, which is exactly why they appear perfectly black to us. Light just gets swallowed whole into the void.
And if you somehow kept falling past that event horizon, you'd reach the absolute center, the singularity. This is where human science simply throws its hands up in defeat. At the singularity, density becomes infinite. The rules of physics just surrender. Time, as we know it, completely breaks down and stops functioning. Space itself folds in on itself like a piece of pasta. Our entire mathematical and scientific understanding of reality simply ceases to exist in this one microscopic point in the dark.
Which leaves us with this final, truly provocative thought. We started out today by looking at the incredible, precise physics running the touchscreen in your hand, the microwaves in your kitchen, and those GPS satellites orbiting our planet. But if those exact same laws of physics, time and space, can completely break down and fold like pasta out in the cosmos, well, what does that mean for our understanding of reality right here at home? It really makes you realize that the everyday magic we completely take for granted is just a tiny, fragile sliver of a wildly mysterious universe. Thank you so much for joining me on this explainer. Keep asking questions, and I'll see you next time.